So this is our last video and lesson for Chapter 5. Chapter 5 is going to take everything we have been talking about and putting it together. But I'm also going to use a form that I set up for you a couple weeks ago to help you do some of the math problems we were doing then. When I look at the information I'm looking at, I'm going to be trying to figure out what a certain number is if I know a whole and a part and a percent, then what it's going to be equal to. The information I'm given in this first example from your very first page, it says a percent is equivalent to the ratio of a part to a whole. Suppose there are 20 marbles in a bag and 5 of them are blue. Well, the whole is the total number of marbles, 20. The part is the number of blue marbles, 5. The ratio of the part to the whole would be 5 to 20. It's going to be equal to the percent of marbles that are 25% out of the 100 that we know have to be there for a percentage. Now when we do these, the book is going to have you going through several different steps. And if you prefer the steps, I'm going to let you do those steps as long as you're successful with it and you're able to repeat that process over and over again. I'm going to teach it though, once we get past the first couple, of only doing divide the loop. I honestly believe that every one of you is going to be more successful if you divide the loop in this process. It's why I introduced it a couple of weeks ago, because it's a process that can be applied in several different situations. If it's a multiplication of fractions problem, it doesn't work there, and I had a couple of you trying that on your homework. The dividing the loop only works when I have equivalent ratios or equivalent rates or unit rates where I know that that one fraction has to be equal to the other fraction. When I'm multiplying, I'm taking a fraction of a fraction, and it doesn't work that way. So let's look at what I'm talking about. All this information here that they give you in that first problem is written out then like this. That out of my part, I'm also going to compare it to my whole. And if I have 5 out of my whole of 20, then I can find my percent. I find my percent because I know a percent has to have what as my denominator. 100, right? So I would take 20 times 5, and I know, since lesson 1 of chapter 1, that if I multiply my denominator by 5, I have to turn around and multiply my numerator by 5. That's always going to be mathematically a sound practice. So I end up with 25 over 100. I keep my numerator, and I add my percent sign, so I know it's 25%. Now, several different steps to get to the same place as when we talked about dividing the loop. So when I divide the loop, I'm always going to set it up as numerators are going to be a total number compared to the part of the number. So it's always going to be the numbers that I have or that I'm talking about in my scenario. The bottom numbers, or my denominators, are always going to be my percent. It's going to be total to total. So I have 20 total marbles, and I know my total percent will always be 100%. It's kind of like that previous video when I talked about percents with the donuts. I could eat one donut in several different bites, still eating one of them, or 100%. I could eat a dozen donuts. I'm talking about the entire group, so therefore I'm still eating 100% of that dozen. My total is always going to be 100%. However many I have in my group, that's going to be on my top. I'm going to use the part number that I'm given, such as the 5, and then I'm going to have my partial percent that I'm looking for. So what I'm going to do here is I'm going to prove that, as they said, it's 25% in all those different steps. I have 20 marbles. All the marbles being 100%. I want to know what 5 of those 20 is as a percentage. So when I divide the loop, once again, I multiply the two that are together. That gives me 100 times 5, which is 500. And then I divide by the lonely number. So I'm going to divide my 500 by 20. And when I divide 500 by 20, I do indeed get the 25. So I know that it's 25%. That's a sound practice that you'll be able to use from this time forward in all of your mathematics classes. The only thing is, I had a couple of you, once again, trying to use this process in a multiplication of fractions problem. A multiplication of fractions problem is, what is the fraction of this fraction? they have to be multiplied across to get my numerator and denominator. This is the equal sign in the center, so I know they're equivalent. They have to be the same value. So if I'm given 3 of those digits or 3 of those numbers, I can find the missing one by dividing the loop. So let's look at the situation that we have set up here. Emily has sent 28 text messages so far this week. That is 20% of the total number of text messages that she's allowed in 1 week. What is the total number of text messages that Emily can send in 1 week? So when I look at it, they give me this graphic source, which is a number line. What they want you to look at is, well, if I know it's 20%, well, how many chunks of 20% is there in 100? Well, 20 times 5 is 100, so I'd have to have 5 chunks of 20%. So if I'm looking at that, then I know that if I had 20 and I multiplied by 5, I would get my 100%. Well, down at the bottom, if I know that 28 is what's equal to my 20%, so I multiplied my 28 by 5, I would know how many I'm talking about in my total text. And 5 times 28, is 140. So we're saying that Emily can send, or 28 is 20% of 140, so she can send 140 messages. When I set it up mathematically to divide the loop, or to go through all the different steps, I have to think about every single situation or scenario that it's asking about to fill it in. It says first to write the relationship among the percents, the parts, and the whole. So I know my percent is always going to be equal to the part compared to the whole that we're talking about. And here they were talking about 20%, so I would know that my 20% is equal to 28 out of my whole. But we didn't know what the whole was yet. So when I set it up then, I end up with 20 over 100, because once again, 20% is always going to be out of my total percent, and my total percent is always going to be 100%. And then I equal to the parts that I know, which is 20 is equal to 28. I don't know what that denominator is yet. So as we move on then, it says, well, that I'm going to take my 100, and I'm going to divide it by 20, which is 5. So what they're ending up with is they're ending up with a unit rate. It's just upside down, because they thought, well, if I get 1 in my denominator, then that's going to make my math easier. And there's nothing wrong with that, because if I take my 100 divided by 20, I get a denominator of 5, and I divide 20 by 20 and I get 1, then I know multiplying 1 by 28 gives me 28. And therefore, if I multiply my 1 by 28, which is my numerator, then I have to turn around and multiply my denominator by 28 as well. And when I do that, and I get 5 times 28, it is indeed 140. So we are once again talking about 140 messages that she can send out of a total. If I go to just dividing the loop, then I just simply fill in the information that I know. I know that I have 20%, and that 20% is equal to 28. So when I divide the loop, I'm always going to put the parts on top that they give me. I know what the percent is. It's going to be on the left. And I know what I have, which is the 28. It's going to be on the right. The bottom then is always going to be the whole we're talking about. And at the bottom, when I'm talking about the percents on the left, it's always going to be out of 100%. This is what I was looking for. So once again, I'm going to divide the pairing that's there diagonally. So I take 100 times 28, and I get 2,800. And then I divide by the lonely number, which is the 20, and 2,800 divided by 20 is indeed 140. Once again, I truly believe that dividing the loop is a lot easier than going through all of these steps to figure out what it is we're looking for. Well, let's look at this one. It says 24 is 5% of what number? So once again, when we say the word is, that means equals, right? So I know that 24 is equal to 5%. So when I go through this information, I have my percent is equal to what? It's equal to my part that I know, which is going to be the 24, over the whole, which is what I'm looking for. So 5%, which is what I'm talking about, is going to be equal to what? Well, when I do the information, I know that my 5 is equal to 24. So once again, the equal sign and is go together. It's kind of like 95% of the time when we see of, it's going to be multiplication. Sometimes they put of in a sticky situation and in a different place in the story. That's that 5% that it doesn't always mean multiplication. But if it's between two numbers or two pieces of information, I know that it's multiplication. When I see is in between two numbers or two situations, I know that that means equal to. So as I work through it, and I just set it up to divide the loop, I know I have 5%. Percents, once again, are always going to be on the left. It's going to be equal to whatever the whole or the parts are as far as the number. So I have my partial percent, I have my partial number. So 5 is equal to 24. My denominators are my wholes. 5 out of what? Well, 5% out of 100%, because it's always going to be out of 100%. What am I left with? I don't know. So I'm going to divide the loop. I'm going to multiply the 124, because they are the two that are paired together. When I multiply 100 by 24, I get what? I get 2,400. I divide by the lonely number, which is the 5 by itself. So 2,400 divided by 5 gives me 480. So when I'm talking about what number am I looking at, 24 is 5% of what? What's 5% of 480? Well, let's look at the practice problems then. Find the unknown value. I don't need to use this unless you really feel like that's the best way for you to do it. If that's the best way for you to do it, let's talk about it, what it's telling me. I know that I have 25% of something. So when I look at the top, well, 25% goes into 100% how many times? Once again, the comparison of money, I have quarters, and there are how many quarters in a dollar, which is my 100 cents? There's 4 quarters, right? So 25, 25, 25, 25. So if I have my 25%, and it goes in 4 different times into 100, so I would take 25 times 4 equals 100, so 9 times 4 would give me 36. Well, if I set it up mathematically, the way we were talking about with dividing the loop, then I know 25 is 9. That's the way I want to set it up. I'm always going to look at what my percent is, so my equals to, my part, so that I know what order to put them in. It's almost always going to be backwards in the actual math problem. So don't let that confuse you. Put your percents first so your math is a little bit easier on you. So I'm talking about 25 is 9, and this is the percent column. So my percent is always out of 100. So then I'm left with dividing the loop. I'm going to multiply the 2 that are there diagonally. 100 times 9 gives me 900. And then I'm going to divide by the 1 that's left, the lonely number. So 900 divided by 25 is 36. And when I went up here and went through all this process, I said 9 times 4 was equal to 36. That does prove that that step works also. It's just harder to get to most of the time. Let's look at number 2 then. Number 2 says 14 is 10% of what number? So I'm going to look at how to set it up first. Once again, I'm going to put my percent first, which is backwards compared to the math problem. So I'm going to put 10% is 14, and then I can set it up. In my fraction, once again, on the left will be percents. On the right will be the numbers that I'm working with. I'm told that I'm using 10%, so it's going to be my numerator. And then my numbers that I'm working with, my part of my numbers is 14. If 10 is 14, and I'm always talking out of 100%, then what is the total that I'm looking at? Well, then I'm going to multiply the 2 that are there diagonally, and divide by the lonely number. When I set that up, 14 times 100 is 1,400. And then when I divide by 10, 10 goes into 1,400 140 times. So that would go on my answer line. I know that 14 is 10% of 140. When I go to number 3, now I'm looking at 3 is 5% of what number? 3 is, so that means that my 5% is equal to a total number of 3. I go to set up my dividing the loop, so I know I'm going to have 5 is 3, my percent to my whole numbers. What is my denominator on my percents? It's always out of 100, right? So I'm going to have 100, and then when I divide the loop, I multiply the 2 that are diagonally, I divide the 1 that is lonely and on its own. So I'm going to take 100 times 3, that'll give me my 300, divide by the lonely number, dividing by 5. 5 goes into 300 how many times? Handy dandy calculator, 300 divided by 5 gives me 60. So I know that 3 is 5% of 60. On number 4, 12 is 60% of what number? So once again, I'm going to put my percent first. So I'm going to write 60 is equal to 12, right? Because is equal. So 60% is equal to 12. And then I set up my divide the loop. My percents once again on the left, my numbers on the right. So when I go through that, I have 60 is 12. My denominator, 60% has to be out of 100%. So then I multiply the 2 that are together diagonally, divide by the lonely number, 100 times 12, divided by 60. 100 times 12 gives me 1,200. When I divide by 60, handy dandy calculator, 1,200 divided by 60 equals, or I could take off those zeros and have 120 divided by 6. Still going to get 20 every single time. So I know that 12 is 60% of 20. The only problem that I'm going to foresee, and I hope that I don't see it, is that you're not going to want to show your work. And if you don't show your work, once again, I'm going to count it wrong. You have to show your work, no matter how basic it is. Even though I warned you on your fractions, decimals, percent page, more than half of you missed 12 points for not showing work. It's very basic work to show. This is not difficult math. Show me that you're dividing, then use your handy dandy calculator and divide. Then you'll be okay. So we're going to do a couple more. We're going to do these, and then we're going to look at how they use it in a story problem also. Once again, please show your work and follow along and write this information down. This is how you're going to know at home how to do it, or you can get online on YouTube, Trace, T-R-E-S, space Barker, B-A-R-K-E-R, and that'll take you to my videos also. Just make sure you look at the right one. This one is 5.6. 16 is 20% of. So all of these are set up the same way. They're all going to be done the exact same way. So I'm going to take my 20% is, or equal to, 16. I'm going to set it up in my comparison then to divide my loop. So I'm going to take my 20 is 16. I know that when I'm talking about percents, it's always out of 100. So I'm going to multiply the diagonal pair that's there, divide by the lonely number. 100 times 16 is 1,600. And then I'm going to divide by the lonely number, which is 20. 1,600 divided by 20. I could drop off those last 2 zeros and have 160 divided by 2. Either way, it's going to tell me that 16 is 20% of 80. On number 6, I have 42 is 50% of. So when I set it up, I'm going to have my 50% equal to 42, because 50% is 42. set it up in my fractions to compare so I can divide my loop. I'm going to have my percent that I have as 50. I'm always going to make it equal to what it says, so it's going to be equal to 42, my whole numbers. That's my part. And now my part of my 50% has to be out of 100. So then I have it set up to find that missing value. Once again, divide the loop. So I multiply by the diagonal pair that's there. I divide by the lonely number that I'm given. When I multiply 42 and 100, I get 4,200 divided by 50. Type it into my handy dandy calculator, 4200 divided by 50 equals. Or you can see that you can knock off those last two zeros and have 420 divided by 5. Either way, you're going to get the answer of 84. So 42 is 50% of 84. Now here's what I want you to do. I want you to pause the video just to make sure we have this process before I get into story problems and the other ways that they're going to use this information. I want you to work through those two. Okay? So pause the video now, work through these two, show your work, and then we'll check your answer. Pause the video now. Alright, so hopefully you pause the video, you work through those two. Let's see how you did. If I'm given the information that I have 28 is 40% of, then I set it up and I showed that I know that 40% is 28. And then I wrote my fractions, and I have that 40 is equal to 28, therefore 100 is equal to what I'm looking for. You looped the two that are there, and you boxed the numerator that's by itself, or the lonely number, and then I would set it up mathematically as 2,800 divided by 40. That should then tell you that your answer would be 70. Hopefully you got that one correct. If not, do you see why? And go ahead and correct it and pause the video. On number 8 then, you should have gone through the same process. That 60 is 75%. So you should show me that, well, 75% is equal to 60, because once again, that's what that is means. Set it up in my fraction form. I put my 75, my percent, as the numerator on the left. My part, my whole number, on the right. So I have 75 is 60. My denominator has to be 100, because that's the percent sign. Multiply the diagonal pair that's there. You got 6,000. And then you divide it by 75. And 6,000 divided by 75 would have told you that you have 80. So you should, for number 8, have that 60 is 75% of 80. Did you get those correct? If not, you see why. Make sure you correct them so you have the right information to look back at. Alright, so now we have two story problems. And we have two different ways that these are set up. That's why I wanted you to practice on those previous ones before we moved on. Now, just because it looks like it's in a different form, please understand, the math is exactly the same. Some of you get through the front side of your assignments fine, and then you get to the last page and you look at the back and questions 1 and 2, you're like, I don't know how to do these. Question 1 and 2 on the back is always a review of what was on the previous page. So you should know exactly what you're doing if you can do the front page successfully. These questions, they look different, yes, but it's the same work. It's just showing you in a different way. These two, same type of questions. It's just shown in a different way. So let's start on number 12. 40% of the students in the 6th grade at Andrew's school participate in sports. If 52 students participate in sports, how many 6th graders are there in Andrew's class? So what is the information that I'm given? Well, what I'm told is that 40%, which is the students in 6th grade that participate in sports, is a total of 52 students. All of that extra information is just extra information. I know that 40% is equal to 52. Once I have that, then I set it up to divide the loop. My percent's on the left, my whole numbers are on the right, so my 40 is equal to 52. Therefore, my denominator has to be, as my percent, 100. I'm set up with my divide the loop, multiply the diagonal pairing that's there, divide by my lonely number. Once I have that marked, then I'm going to multiply 52 times 100, which gives me 5,200, and I'm going to divide by 40, handy dandy calculator, 5200 divided by 40 equals, some of you see, oh, well, there's zeros at the end. I mark those zeros off and I get 520 divided by 4. Mathematically, that's sound as well. Both of them are going to tell you that there are 130. This is where you have to make sure you have a label. 130 what? 130 sixth graders. All right, so then number 13, still a story problem. There were 136 students and 34 adults at the concert. If 85% of the seats were filled, how many seats are in the auditorium? So we had a question a couple of weeks ago where it talked about people, but the information that was given was children and adults, and it really confused some of you. Well, as a child, you are a person. Your parents are adults. They are people as well. In this situation, the students get a chair, the adults get a chair. So we have to look at what number we're talking about first. The number we're talking about is, I know that 85% is equal to what? Well, I have to put those two together. I have to add the 136 students and then add the 34 children, or adults, excuse me, to know that there's 170 people in the auditorium sitting in a seat. Once I know that, then that tells me that my 85% is 170. Then I go to the space on my paper and I show the work. Once again, if you don't have the space, that's not a reason not to show me your work. Get an extra sheet of paper. Go to my printer and grab a sheet, or go to the box and get some of the lined paper that I have over there for you and staple your work to it, because I can't give you credit if you don't show me your work. So I know 85 is equal to 170. I set it up, percents once again on the side, on the left, so therefore my denominator has to be 100. I'm going to multiply the two that are there diagonally, divide by the lonely number. I have 100 times 170 divided by 85, which gives me 17,000 divided by 85. 17,000 divided by 85 tells me 200. 200 what? Well, this says how many seats. So there are 200 seats in that auditorium. Now, looking at 14. What does this mean? Or is it there to try to confuse you? Yeah, it's probably there to try to confuse you. But it's still set up the original way we have. The only thing they haven't added is what? My denominator, right? This is still my partial percent, going to be compared to my whole percent. This is my partial answer compared to my whole answer. So I'm going to set it up with a denominator of 100. That makes my math a lot easier. I know that I'm going to multiply the two that are there diagonally, divide by the lonely number that's there. So 100 times 32 is going to give you 3,200 divided by 40. Or if you drop those zeros off, 320 divided by 4, still going to give you the same answer. When I divide them out, then I know that this box at the bottom, my missing number, is indeed 80. 15 is the same thing. They are only just trying to confuse you by not telling you that it's out of 100%, but it's set up the same way we've done all these other ones. So just add the 100% to it so that you know we're out of 100. Multiply the diagonal, divide by the lonely number. 91 times 100 is 9,100 divided by 65. So 9,100 divided by 65. I know my missing denominator is 140. This is really very basic math, and every single one is doing the exact same math. Dividing the loop, multiplying the two that are given to me diagonally, dividing by the number that's left alone. So when I'm doing it, just make sure you set it up correctly. Make sure I show the information that my percent is the whole number, which will almost always be backwards in the math problems, so that I know that where I'm putting my 100. If I don't set it up right and I end up with my 100 underneath the number that's given, my answer is not going to be correct. So make sure you set it up percent to whole number, that the bottom number then is my whole percent compared to my whole number. That's the lesson. It's pretty simple. It's pretty basic. You shouldn't have any problems. If you do, go back and watch the video. come and ask questions while you're doing your work. Once again, I would be in the back of the room working with people on doing some corrections and things that they didn't quite understand.